Hi, and welcome to this lesson. This is section 2.5, Becoming a Data Scientist. Becoming a data scientist is not just science, but it's an art as well. And the reason I say that is because, yes, there are methodical approaches and various methodologies and frameworks, and all of the technical knowledge and skill set that a data scientist must possess. But there's also other focus areas, including stakeholder management, socializing the outcomes of the work, having the business sense to understand the problem at hand from a business angle and perspective, ideating for use cases when you're in workshops with business stakeholders across the organizational functions, some level of domain knowledge of the industry as well. And then there's plenty more. Remember the Venn diagram? Just a quick recap. We saw this towards the end of the last session as well. If you have background in any of the fields that are in this Venn diagram, you can pivot to data science, even if it means that you're coming from, let's say, a research background where you haven't really done much of engineering or computing or maths and stats. But just because you bring that experimental design and the hypothesis testing and the robust application of scientific method, this is something very valuable for the data science field. So there are quite a few routes to entry. You could become a data analyst and become a data scientist that way. Or if you have a programming, engineering, software background, data engineer to data scientist. If you are a very highly technical machine learning engineer already, you have knowledge of machine learning, you want to become a data scientist and bridge the technical commercial gap by having access and exposure to business and connecting the narrative, building the story, and socializing it to build consensus across the organization, then of course this is a route to entry as well. Purely if you are a researcher, as I said on the previous slide, you could bring your knowledge of the scientific method and the various designs of research and experimental designs, which is quite valuable to this area. And then any other role to data science really. It's open. What essentially needs to be done is that you do a self-evaluation. Each route has its own needs and requirements. Of course, as I said, you will need to identify for each of these routes and for yourself the training, qualification, skill set delta, and any experience that you might have that you could transfer over and bank upon. You could also start in other entry-level roles such as analyst or visualization developer, BI analyst, etc. And then on the job, train yourself on the side in machine learning and learn from your colleagues in the data team towards becoming a data scientist. With experience and with acquisition of training and skills and expertise, the career tracks, they start to lean towards data science. So in this last section of this second unit of our course, we're going to be doing a summary of what we're going to look in the next unit, unit 3, which is the role of a data scientist. So let's look at what the data scientist does, and this is from a very practical perspective. We've seen the data scientist's job description. So without repeating ourselves here, what we want to focus on is start to narrow this course down on just the one role, which is the data scientist role. In the third unit, we will start to put more detail under each with different tool sets and concepts. And then we will start to get technical in the third unit as well. We'll look at machine learning examples, the concepts of machine learning, fundamentals, some example algorithms. We'll look at visualization techniques and libraries. And then in the fourth unit, we will take a case study to go from end to end, so that you actually start to really get a flavor for what a data scientist does. But coming back to the end of our current unit, unit 2, we're going to just do a quick overview in this section, in this lesson of unit 3, so that you know what's coming up next. So the first thing, as we know, a data scientist has business acumen. They need to have a business understanding. And what is business acumen or business sense or business understanding? It's an awareness of the nuances of a business, the various decisions that need to be made, for the processes that the business has, and the outcomes of all of these activities. Of course, there are some fundamental goals for any business, including economic value, but it could also be business value, and we'll see the difference between those two momentarily. A data scientist needs to have strategic thinking as well. Because they need to optimize strategies with leadership, this is something very important for them to be comfortable, have the broad view, to be able to see the big picture. They should know at least one industry, examples being healthcare, education, financial services, logistics, etc. This really facilitates use case ideation. They can really put their weight into conversations with their knowledge of benchmarks. If they've implemented solutions in the industry before, even better. If you're becoming a data scientist, or if you want to become a data scientist and you are coming from an industry expertise with little knowledge of the data analytics and machine learning areas, you can really start to highlight your experience in the industry and focus on use cases and application areas within that industry to make your CV stand out. Of course, if you are in that industry and you have knowledge of that industry, experience of that industry, then you will know the state of practice and the state of the art in that industry as well. An example could be, let's say, healthcare. You have healthcare systems that are reactive and are providing healthcare services in a reactive manner, dealing with chronic conditions, let's say cardiovascular disease or diabetes. A proactive healthcare system would start to engage the population through awareness programs, different kinds of incentives, running those in the corporate and the academic arenas, running campaigns to get the population and people to change their lifestyle so that these chronic conditions can be prevented. So that's the state of practice, let's say. And state of the art could be that the healthcare system has got electronic medical record system for the patients that all hospitals and clinics across the country use. So you can go to any healthcare institute or hospital or clinic, and they'll have access to all of your medical history automatically. Coming back to the fourth point on the slide here, then process knowledge. If you have some knowledge of the processes in that industry, or if you know how business processes work, and then of course you should have excellent communication skills to be able to work and collaborate with the technical teams, the IT, the data team, the product teams, as well as the business functions, the executive leadership, and so on and so forth. The next thing after business acumen that a data scientist must possess is technical knowledge, of course. And here we bring back our illustration of machine learning types from the first unit. If you recall, we had supervised, unsupervised, and reinforcement algorithms, a few examples of which we had illustrated. What we'll do here is reduce that to say what you must know as a data scientist if you want to become a data scientist. Leave aside the reinforcement learning part and even reduce quite a few algorithms from our list of algorithms in supervised and unsupervised that we need to learn. So let's say if you're coming in cold and you want to learn machine learning, this is the minimum set of algorithms you should start to work with. In supervised, you should know regression and classification. You can do linear, multilinear, logistic regression. You can do k nearest neighbors, very basic algorithm, decision trees and random forests, and then boosting algorithms. You might also do support vector machines, definitely do neural networks, and then Bayesian models, and if not all of them, but at least the most basic one, naive Bayes. And ideally, if you do deep learning in neural networks, this will make you quite current, because this is a state of practice and state of the art in this field. If you remember, this overlap means that these algorithms do both supervised and unsupervised, On the unsupervised learning side, we have k-means clustering, where you specify the number of clusters that you want, which is k. You have hierarchical clustering, recommendation systems, and then dimensionality reduction. When you have a highly dimensional data set and you want to be able to, let's say, visualize it, compress it, you can use this to do that in linear or non-linear fashion. More on the detail of these in the next unit when we start to do a deep dive in technical concepts. Other technical requirements: you should at least know one programming language, ideally Python. You could also maybe come from an R or MATLAB background. You should also know SQL. If you do know R and MATLAB or any other scripting language, it will be straightforward for you to learn Python. You can find very good courses on the internet to learn Python quite fairly quickly. SQL is quite important as well for you to be able to slice and dice data. As a data scientist, you should also know how to set up experimental design, the different types of experiments you can do, what are the different statistical tests to validate your hypotheses. You should be able to do with using your programming language and the various libraries, data pre-processing, and then big data platforms, Spark, etc., mathematical statistical analyses, the different types of machine learning algorithms, and the underpinning mathematics of it all, calculus and linear algebra. The state of practice has evolved quite a bit in the last couple of decades, let's say, especially since the advent of deep learning. Now we see a lot of programming environments, a lot of drag and drop options available for low code, no code development of data solutions. As a data scientist, it's always ideal and the best way to know what's under the hood or the bonnet. So if you are aware of the basic machine learning and basic statistics and maths, you'll always be able to build a statistical model by tweaking the hyperparameters of the algorithm and by lifting and shifting, because you're aware of what you're doing. Sometimes you see practitioners don't know the underlying concept so well, and they struggle to then tweak the algorithm. They use the default parameter values for the different methods and just call using libraries, and it becomes quite similar or akin to what a layman would do by dragging and dropping an algorithm or a method in. The third thing that a data scientist should be doing is visualizing. Data needs to be illustrated in different forms, even animated visualizations, not just charts and plots. This really supports, facilitates, promotes communication of complex data relationships and trends and patterns, and immediately makes this understandable for the audience. All of the meaningful insights that you might see as a data scientist in numbers might not be directly communicated to the business or other parts of the business. So illustrating it, visualizing it, helps a shared common understanding across the business and the organization. There are many libraries and frameworks out there. I've listed a few open source frameworks like Matplotlib and Folium, Plotly, Seaborn, etc. Then the penultimate factor or thing that data scientists needs to be doing is building a narrative, the art of storytelling. How do you actually explain complex data patterns to people? Well, we've seen and we've said before that visualizing it helps. The next bit we can do is to put together a storyline, and this narrative that we put together should be such that the story that is within it resonates with the audience, has some kind of a starting and an ending, an outcome, shows some kind of a climax, and maintains flow and rhythm and is engaging and captivating for the audience. It helps optimal sharing of data insights because the audience really starts to own this story themselves, and it helps to build consensus across the organization that the empirical insights can actually bring value to the business. To create a good story, we need to have data that we've selected carefully, cleaned, pre-processed, analyzed. We need to be able to spot that story in the data as we explore it and build that narrative. Once we have the narrative, we need to be able to have supporting visuals that we'll take to the business and to the audience when we're presenting this narrative. And then it needs to have an outcome or an ending that has direct business value. But more on this in the next unit. And finally, driving business value. Business value can be a measure of organizational well being. It's not just economic value or profit, it can be tangible or intangible. So, examples of business value include customer satisfaction, intellectual capital of the company, minimization of risks, optimization of pricing strategy, ahead of time prediction, customer base growth using personalization, staff productivity, cost reduction, and sales increase, and so on and so forth. So, to summarize this lesson, this section, and the unit, we have some kind of a company that's interfacing with the market. It's offering its product or some kind of a service to customers in the market. The market is giving economic value in return to the company. But what happens in the background? Well, this company needs to optimize its services and products so that it always remains current in the market and is able to receive that economic value steadily. So, in the background within the organization, it has some assets like technology, data. Let's call this the technical domain. And then there is a divide between the technical and the commercial, and the data scientist sits in the middle. And the job of the data scientist is to straddle this gap or divide or dichotomy between the technical and commercial domains and connect these together by understanding the business problems with the commercial teams, liaising with the business function to find those problems, look at the data, understand how to solve that problem using data, and connect those two together using visualizations, narrative building, modeling, machine learning, AI, and the entire data team and product team and everyone else that's relevant to the project and the solution. So it's quite an interesting and quite a complex task and job. By doing this, the data scientist is able to generate business value for this company. And this brings us to the end of Unit 2. I hope that you've learned from and enjoyed this unit, and I look forward to speaking with you in the next one. Thank you.